my job today is really to give an introduction about the topic of digitalization. One thing to say about us, about the Policy Links unit, is that we mainly work with governments. So I will be speaking about the projects that we do with governments here in the UK and abroad. But our colleague thought that there's some interesting material here and some ideas that might be relevant for companies as well. Now, just one thing about Policy Links is that our mission is to help governments develop more effective industrial innovation policies, and we do that here in the UK and abroad. Now, these days you cannot really talk about digital manufacturing without saying Industry 4.0. And this is a standard picture. Probably you've seen this many times, but it might be worth just to go into a couple of elements. So the term Industry 4.0 came about from the German government's strategic initiative, the New High-Tech Strategy. It really was going in the Hanover Messe Fair 2011, and it's been around and is used now by consultants, academics, and policy officials alike. Basically, and the fundamental concept here is that the fourth industrial revolution is an anticipated industrial stage that follows the first industrial revolution, in which production was mechanized using steam power. Then the second industrial revolution, in which we achieved mass production using electric power. And the third industrial revolution, in which we started using ICT and electronics to automate manufacturing processes. The fourth industrial revolution that refers to the autonomization, the hyper-connection of industrial systems using technologies such as Internet of Things, big data, artificial intelligence. Sure, you have seen versions of this picture many times, but perhaps something just to emphasize here is that the big change that we observe is, obviously in the first industrial revolutions was about the power source. So we changed from steam and electric power, and now it's about the data and the manipulation methods of the data. The amount of data, our ability to process that data and to analyze that data. So of course, you have seen many of these definitions. Broadly speaking, we think Industry 4.0 refers to the widespread integration of ICT in manufacturing. But it is the first industrial revolution to be named before has actually happened. That is the one industrial revolution that is different to the previous one. Now, you have seen probably as well a number of these kind of grand statements. We live in a period of rapid technology change, more change. We're entering a new industrial revolution. Everything is changed. And probably you have seen these kind of statements, probably in the media. And perhaps one of the reasons why you have seen this statement is because they have been around for quite a while. This was the day I entered to university to study actually mechatronics engineering a few years ago. Well, exactly that. No, I was 1 year old when that happened. So we've been yeah, I'm not that old, sorry. So we've been discussing this industrial revolution for a while now, and of course, the fact that we see these grand statements about us living in unprecedented times really makes some people skeptical about this topic, and to some extent, they're right to be so. So it is true, not everything is new. We have always had sensors. I mean, we're in sensor city, so they probably know the history of sensors better than us. But we have had sensors for some time now. We have had lots of data for some time now. We're using data analytics and simulation in manufacturing for some time now. But what is new has to do with the cost and the power of sensors. Again, we're in the right place to discuss this. The fact that we have now many more devices connected, not only within the firm, but across supply chains as well, but across the whole manufacturing system. And the fact that customers are more involved using mobile and personal computing throughout the manufacturing process, throughout the design process, and throughout the engineering process as well. So from the design to the production to the feedback of how the products are being used. So this is really new. We see then, we can actually test and we can see that new opportunities are arising because digital applications are becoming cheaper, easier to use, and more widely tried and tested. More importantly, we can say this conceptually, but we can actually test it empirically as well, because there's growing evidence of the firm level improvements that are being achieved, not only in this country, but across the world. So I will be talking to you a little bit about these opportunities that we are seeing in our work related to the applications of digital technologies in manufacturing. One piece of work that we've done last year is for Innovate UK. They wanted to understand what is the evidence that actually makes sense for government to support digital manufacturing. So we looked around 70 initiatives around the world. Some other countries have started before the UK, and we collected over 1,000 individual case studies. These are single case studies of single companies saying how they're using digital technologies, where are they using them, and what are they achieving from that application. 212 of these we analyzed in more details, and I'm going to tell you a little bit more about what we found. The first thing we did is to cluster these applications in terms of whether they're being applying, companies are being applying these applications on single or multiple processes. So whether it's just one process or the whole line, and whether they're being applied in single or multiple companies. So whether it's just one company, we're talking about wider supply chain applications. We also clustered them in terms of where in the manufacturing decision areas they're being used, and things like the product and the process design, the process itself, the infrastructure, the enterprise management, business and technology environment, and obviously there are definitions of all of that. And basically this is the kind of pictures that you get, which tells you not a lot, but it does tell you that it's been applied everywhere. And that's first observation actually, is that you start judging the value of purely technology push approach, because basically what it tells you is that you can apply it everywhere in the company. So it also tells you the difficulties that managers have when deciding where to start or what is the right thing to look at in their businesses. And I think my colleagues later will be talking more about these strategic decisions and how do you merge the technology push and the strategy pull to make sure that actually you achieve your objectives. This is the graph that you get when you map in the manufacturing where are these applications being used. This is actually, again, this is not theoretical, this is actual data. You take all the companies' cases, take a look and classify where they be used. So this is, and from around the world, we have maps like this per country and per sector and this kind of thing. But generally, this is a picture. Most of the cases, around a third of all cases, are being, companies are using digital technologies to improve single processes. So process control and optimization, fewer applications in things like production planning and control, and even fewer in things like product design and definition. Okay, this is just tells you where they're being applied. So this is the kind of pictures. Again, it depends on the country, it depends on the sector, it depends on the type of company, where we're talking with large and small companies, although this is mainly small companies. Nationally speaking, these are the kind of results that government expect to achieve in variables that governments care about, like productivity and jobs. So this is what they forecast that the applications of digital technologies can achieve in their countries. On your left-hand side, and on your right-hand side is actually, more importantly, is the observed impact. So these are actually measurements that national initiatives supporting digital manufacturing are obtaining from the application in firms across the countries. We have data from various countries. I just wanted to highlight here Singapore and Korea, perhaps the countries that are doing it more systematically. Interestingly, both are reporting manufacturing efficiency improvements of around 30% in the samples of firms that are analyzed. Again, they define manufacturing efficiency in different ways, but interestingly, they're both reporting the same kind of numbers. If you want to know more details, of course, you can go to Korea, because they're actually monitoring systematically more than 3,000 SME applications, and you can actually get more data, and actually that's what we're looking at in single firm level applications. Now, but then you can move to what companies really like, or what companies really care about. The language that companies speak, we're talking about increasing revenue, reducing costs, reducing working capital. You can also classify that kind of impact from our case studies in these kind of terms that are probably more familiar to companies. And you get all the subcategories there as well. Now, this is a difficult graph, it's a busy graph, but what it tells you is that there is a lot. So all these are the variables that we mentioned before: increase revenue, reduce cost, reduce working capital. So what it tells you, the first thing is that there's a lot of variability between the impact that companies are reporting. It has to do, again, because the applications are in different contexts, in different environments. These results are mainly self-reported. Companies are reporting themselves with no standard methodologies. But despite the variability, the data suggests that the positive impact in business value. Just to give you some numbers, these are the medians of the sample that we have analyzed, coming out from these national initiatives that I've mentioned, in terms of what they have achieved. They have achieved around over 50% in terms of labor costs. Again, depends on how they define the labor cost, but it's usually in how much I'm spending in terms of labor that is using this machine before and after the application, defects and errors, material costs, increasing outputs. This is the kind of data you get. Similar results found in other studies like the World Economic Forum, by the way. What is interesting as well to find from this study is that you might find that the most popular applications are not always the most valuable from the firm perspective. So for example, this is just a sample. If you look at those companies that achieve reduction in labor costs, more likely were using applications focused on process control and optimization. However, the ones that give them the best results were those that were focusing on process design and definition. So it is an issue about how you approach the problem, whether you go directly to a process or you think about reconfiguring the product itself and the process altogether. So of course, there's a lot of implications there, and you can analyze as well from different variables: material cost, delivery performance. Again, also it's very difficult to know that whether that labor cost is more important to the company, because you might be a chemical company that with a 5% reduction on energy costs is much more valuable than a labor cost in a single operation. So again, that depends on what the company cares about. Now, moving to the barriers. These are opportunities. We think opportunities are real, but so are the barriers. At the system level, we analyze the barriers because to inform government actions is not only about company issues, but we're talking about the whole environment. So one way in which we look at this is by classifying the barriers in terms of the generation, barriers to the generation of the technologies, to the diffusion of the technologies, and to the deployment of the technologies. So this is a basic innovation system concept, and we have reported these kind of barriers that we encounter in government and initiatives around the world. For example, in terms of the generation, is government might not be investing enough in the right type of R&D. It might be that companies don't have certainty about the applications, and you might have the technology, but you don't know how to apply it in manufacturing. Diffusion has to do with lack of standards, interoperability between systems, obviously awareness, and a lot of concerns about cybersecurity. Big studies coming in from US and other countries regarding cybersecurity for manufacturing. The Italians are big targets of that, not because they want to steal their financial data, but because they want to steal their designs. Deployment, low absorptive capacity. Of course, companies do not necessarily, even if the technology is there, even if they have the money, they don't have the know-how to apply this. We have legacy systems in those companies, and obviously lack of skills. Anyway, this is a way to classify, and why it's interesting for us to think about this way is because they all become policy targets. Is it whether supporting a program for R&D funding, whether it's paying more attention in standards development, or whether it's hands-on firm support, like the Made Smarter pilot in Manchester at the firm level. Another way to look at the barriers is at the firm level. Really, this is I'm sure you're familiar with this, stages on the process of manufacturing innovation. Pre-installation, you need to make decisions, whether go or no go. Then you install and commission that innovation in your process, and then whether it's working, then you can start measuring. You can move to post-commissioning and start measuring. Now, the technical success does not always mean business success, and that's why it's interesting and important to think about the success measure at different stages. So the first stage is obviously the strategic alignment, but you don't know that until later. So you cannot know that. You might know technical success because you have parameters of improvement, but you can only know the realization of business value once you compare to your strategic objectives. And then you can think whether the alignment was correct or not. So what can you do if you really don't know this until the very end? And that's what the kind of work that we're trying to do in this project is to try to map the barriers that you might face and how you might be able to align strategic objectives and technical success, building on the experience of others. So if you take those steps and you also map, there's a lot of concern about barriers at the organizational level, but again, experience of projects like Mace Martin and others around the world, what you find is that it might be, they're very important barriers at the individual level, at the market level, at the policy level. So what we're doing is mapping these kind of barriers, and you'll find things like, it looks like this. It's just obviously not easy to read, but you'll find things like there's no awareness by the decision makers in the company. The decision makers might not be here. They might be in the mother company somewhere else. Lack of technical expertise. So this is at the individual level. It's just managers don't know, technicians don't know. Organizational level, no roadmaps, which tells you, again, the issue about alignment. If you don't have technology roadmaps with your market trends, it's difficult to know where to start. Technical challenge for system integration. This is a key issue because it is not only about ICT or mechanical engineering applying more ICT. It's about more ICT engineering that needs to know more about manufacturing as well. So technical challenge, big issue, underfunded potentially in some programs because it's not well understood. At the market level, as you know, in highly regulated industries, pharma, even obviously aerospace, even auto, process change requirements are costly. So if you have a process that is running, your client is not necessarily going to be happy if you change it. Lack of trust and unclear contractual arrangement. Who wins from the savings? Is it just the company or is it also the client? So that might not be clear. And at the policy level, these silos between R and D. So these are only programs for research, so you shouldn't be doing deployment or development, or this is only a deployment and development program. Why are you doing some research? So these silos you see appearing in programs, and obviously you need both to act together. And the policy as well, things like outdated evaluation frameworks that are measuring new patents or new papers when what you're thinking about here is, again, alignment, business objectives, how many new SMEs are involved in innovation, etc. Those are the kind of barriers that we're mapping. And just to finalize, this is my last slide, is that, well, the hype is real. It is true, that is real. But so are the opportunities and the barriers. The opportunities go beyond single process automation. So we see these opportunities across manufacturing functional areas, across to address different business objectives through different types of innovation. Full value, there's this very interesting study around in Korea and why we only have applications in single enterprises, not throughout the supply chain. That's where it's going to be in the value, but obviously there's a lot of complexity as you add up complexity of single companies, and then you have bigger complexity at the system level. So that's still not realized. That's what the fourth industrial revolution is an anticipated stage, is because the full integration still hasn't been achieved in many sectors, and the longer the supply chain, the more complex that integration is. Digital innovation, however, is providing a very interesting motivation for companies to rethink their competitiveness strategy and for governments to rethink the role of technology. So the hype might be actually useful in that sense to rethink where we are and where we want to go. Barriers go beyond technology. Technology is just half the battle. It's before making the decision, during the implementation, and after the implementation. They could be individual, organizational, market, and policy or regulatory barriers. And finally, there is what is the opportunity as well. We think is that, well, this has been done across the world. There's a lot of international experience that can help better understand what the opportunities. to guide these decisions, to identify mitigation strategies, and my colleagues after my presentation will be talking about specific examples of how you address these barriers. I'm just telling you the problems, they're going to tell you the solutions, and also inform policies. And just finally, this obviously you can get more information about the report I've just presented in our website, or if our website is in there. And we have published recently a report on safety and security, so cyber security and cyber safety for manufacturing. And please go and read it. Thank you.
Thank you very much, Carlos.